Good everyone, my name is Graphics. Today we want to analyze this question in statics, which is an aspect of mechanical engineering science. And the question goes like this. It says a roller of mass 80 kg is pushed or pulled with a force of 300 Newton acting at an angle 45 degrees to the horizontal grass surface. Ignore friction effect in this question. Now the key word here is the push force or the pull force is inclined. Now let's do this analytically before we go into graphical aspects. In the analytical way, right? This is the mass here, right? It is inclined, right, at an angle of what? 45 degrees. And the force is what? 300 Newton. Is that taken? So what you need to know, the fact that it is inclined, you have to what? Resolve. But we know the weight, the mass, the weight of the roller is given as W equals to what? Mass times what? Gravity. Now what is the mass? The mass given is what? 80 kg, right? So 80 multiplied by, let's say gravity is 10 meters per second square. So we say that our weight is equals to what? Our weight will be given as what? 800 Newton. So the force acting down 800 Newton. But in this case here now, you have to resolve this. So if I want to resolve this in my free body diagram, this is going to give me vertical component here will be 300 sine 30 sine 45. I told you whenever it is inclined to the horizontal, if you watch my previous video, you get to understand this. And in this aspect here, this would be what? 300 cos 45. And this one is acting downward this way, which is what? The weight, and that is what? 800 Newton. So we know very well that the force acting to the horizontal is 300 cos 45, right? So the horizontal pull force, you cannot write that. The horizontal pull force is equals to 300 cos 45, and also the vertical pull force is equals to what? 300 sine 45. So at the end of the day, both of them, you have the force to be what? Both, we say that our force, our pull force will now give us to what? 212 Newton approximately. Is that taken now? So this is the analytical way of doing this. Now let's now do this in the graphical way and see if we are going to get this force here that we have. So we'll go to our graphical method. Now we want to analyze this question graphically and see if we will have a corresponding value. Now the first thing you do is to set your scale, right? So maybe I will say that the scale I want to use should be to every 1 unit, right? I'll be measuring what? 2 millimeter in the y-axis, and also to every 1 unit I will have 2 millimeter on the x-axis. So one thing I want to bring to your notice is this, is that if I have a square, is that again? We know all the angle in a square is 90 degrees, and the force, the distance in the x-axis is equals to the distance in the y-axis. That is the square. All the sides are equal. Now if I draw a diagonal, it means that what? I'll be having 45 degrees, right? So what I'll do to this my graph is that I'll make the distance along x to be equal to the distance along y. So let me assume that I want to take 40. If you like, you can take 50, you can take, it depends on what you want to take. So if I use my graph and I want to take 40, right, I've already said every 1 unit is 2 millimeter. That means 1 unit here, this line here is 1 unit, this is another unit, another unit. So the first cell here is what? 20 millimeter. What I'm going to do is I'll draw my vertical and horizontal axis. Let me just take this point here and draw my vertical and horizontal axis at this point. Right? So at this point here, I'll start from here. I'm going to draw this way. Draw this way. So this will be my 0 origin here. And also I am going to draw for my horizontal too, this way, like this. Sorry, this is my horizontal. So I'm assuming that I'm taking 40 millimeter. Let's take 40 millimeter along x and along y, right? So I say every 1 unit is 2 millimeter. So if I start from here to here will be 20, right? And from here to here will be what? 40. How? I said every 1 unit is 2 millimeter. So this will be 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, then 20. So the first cell here is 20, second cell here is 20. So this is where my 40 will be, right? So this is 0 and this is 1 and this is what? 2. So now this is my x-axis and this is my y-axis. So at 1, if this is also my y-axis, I also have the same thing. This is 1 and this is what? This is 2. So when 1 is 1, it meets here, and when y is 2, x is 2 will meet here also. So we're having something like this at this point here. To stop here. So where x and y meet is at this point here. So we need to be very sure meet at this point here. Right? So this our line here is our force, because that is where the distance at 2 along x-axis meets that of y here. This is where they meet, the point of intersection here. So this will be my force of 300 Newton. This is the force of 300 Newton. F is equal to what? 300 Newton. So what is the distance I'm going to measure? So I'll measure from here to here. 1 to this. So this is 0, 10, 20, 30, 40, 50, and I'm having 55. So let me say 56.5. Right? So I'm assuming that 56.5 millimeter is equal to what? 300 Newton. And distance from here to here is what? 40 millimeter. And from here to here is also what? 40 millimeter. The force will be the 300, that is the force along x-axis, will be the 300 multiplied by 40 divided by what? The force here, which is what? 56.5. So long run, my force around x will give me 212.3 Newton. So you can use your calculator and you press that. When you multiply this 300 multiplied by the distance 40 divided by this scale in here, which is the force in the length here, and you're going to have 212.3. Similarly, if you want to do for the vertical component also, you multiply, because vertical and horizontal are the same thing, so you multiply the 300 multiplied by 40 over what? 56.5, and you get that. So thank you for watching. If you've benefited from this video, don't forget to click on the subscribe button.